Hello guys, today we will be discussing about circle theorem, and make sure you listen closely to the discussion that we're going to have today, and don't forget to take down notes. Okay, see you in class. Mathematics Online. Don't forget to press the subscribe button and the notification bell for your daily class updates. Today we will be discussing circles theorem, but before we're going to do that, let's review first what are the parts of a circle, because we will be using this as we move forward and learn the theorem about circles. All right, let me draw a circle here. All right, let me draw a circle there. Now the point for which we can see there is what we call the center. Alright, the point for which we can see is what we call, here is the center. Alright, the line that connect from a center to the circumference. Okay, the line that connect from the center to the circumference. This is what we call, here we call this one as radius. Now the line that connects from circumference to circumference, the side of the circle, but passes through the center of the circle, is what we call, this one here is what we call diameter. Alright, that's what we call diameter. And this one here is what we call circumference. Alright, that's what we call circumference. Now there's a certain line that connect just from edge to edge of the circle, alright, from edge to edge of the circle, but does not touches the center of the circle. This is what we call here chord. Alright, now the segment, okay, the segment, now the part inside the chord from the circumference, this one here, alright, is what we call this one here. This is what we call segment. And the part for which, yes, the part for which a radius, inside the radius and the diameter, this one here, this is what we call alright, this is what we call here as the sector. Okay, next, remember this, and remember this, diameter is equals to 2 times radius, and radius is just equal to diameter divided by 2. Alright, now there is a certain point also in a circle like this. Okay. Alright, like that. Okay, now the point for which, remember this, that touches, alright, that touches the edge of the circle on every line, this is what we call a here. Alright, this is what we call a tangent point. And here, this is what we call tangent line. Alright, that is what we call a tangent line. And this one here is the point. Okay, a tangent line is a point. A tangent point is a point that touches the edge of the circle. Okay, remember that one always. Again, diameter is equals to 2 times radius, and then radius is equals to diameter divided by 2. And these are the parts of the circle. You have here a segment, a chord, a diameter, a circumference, a sector, you have a center, a radius there, you have a point, you have a tangent line, and you have a tangent point, for which tangent point, that is the point that touches the edge of the circle. Alright, so I hope the parts of the circle is clear. Now let's move on to the theorem of the circle. The first theorem, angle at the center. Alright, angle at the center. Angle at the center, the angle at the center is twice the angle of the circumference. Alright, remember the word. The angle in the center is twice with the angle of the circumference. Now, I'm going to point out this is the angle of the circumference. And this is the angle of the center of a circle. So you have to remember that the angle of the circle is twice of the angle of the circumference. Alright, so means to say this is 2 times A, and this is A. Alright, twice. Alright, 2 here means twice. Okay, now let's have an example. Let's draw a circle and let's draw an angle inside. Alright, now we have A, B, C, and O. Okay, now we have a if if AOC is equals to 96 degree, find ABC. Now we have here, if we have AOC, so this one here is equals to 96 degree. Find ABC. So we're going to locate this angle here. Okay, now how are we going to do that? Okay, how are we going to do that? First is you have to remember that this one here, alright, you have to remember here that this one here is twice of the circumference. So if we have AOC is our center angle, so therefore this is 2A. So if we're going to look for ABC, we are now going to divide 96 divided by 2. Alright, 96 divided by 2, which gives us the answer of what? What's the answer? Is equals to 48 degree. So therefore this one here is equals to 48 degree. Okay? Okay? So that is how you're going to do that. So this one here is just divided by 2. And if you are going to look for here, and you have 48 degree times 2 is equals to 96 degree. Okay? Next. We go for the next theorem. The second theorem is what we call the angles in a semicircle. Alright? Angles in a semicircle. Now, you have to remember, guys, that we go back to the first rule or the first theorem. The first theorem states that the center of the circle is twice of the angle of the circumference. So if we have 180 here, yes, if this is 180 here, if we have 180 here, remember this is twice of the circumference. We divide it by 2. The answer is 90 degree. Therefore, the angle here is always 90 degree. That's why it says that the angle in a semicircle, because we pass through the center, we take the circle into 2 parts. Yes, this is the first part here. The angle in a semicircle is a right angle because this is 180, we divided by 2, and it gives us a 90 degree. Alright, here it gives us 90 degree. So if you're going to multiply 90 degree times 2, and it will give you the center of the circle. Now let's have an example. Let's do a circle here. Alright, let's do a circle here. And we draw one line. Alright, so this one here will always be. Alright, if this one here is 44 degree, okay, if that one here is 44 degree, the question would be if, you know, we have A, B, and C. Alright, A, B, and C. If, let's have an example. If C, A, B is equals to 44 degree, find BCA. Now remember this, guys, last year we discussed this, that the middle letter is the angle. So in this case we're looking for angle C. So therefore if CAB is 44 degree, you're going to look for BCA. So we are going to look for this. This is X. Alright, that is X. Now since that this is an 180 here, because this is a straight line, so therefore the angle opposite to it is a right angle. So this is 90 degree. Now if you're going to have 90 degree, yes, the X plus 44 degree plus 90 degree is equals to 180. This is 180 is the measurement of a triangle. So therefore if you have 44 plus 90 is equals to 180. Alright, 44 plus 90 is equals to 134. Alright, this one here, so it becomes, here we have x plus 134 degree is equals to 180 degree. Next is we move this to the other side, so therefore we have here now x is equals to 180 degree minus 134 degree. So the answer x is equals to 46 degree. So therefore our x here is equals to 46 degree. So this is now BCA. Angle C is equals to 46 degree. Alright, now next we have the next, alright, we have the next theorem. The next theorem, alright, the next theorem, okay, but before that, the theorem 2, remember this, angle in a semicircle will always gives you a right angle here. Alright, it will always gives you a right angle. Now we go for theorem 3. Theorem 3 is the angles in the same segment. Alright, angles in the same segment are equal. Angles in the same segments are equal. Okay, angles in the same segments are equal. Okay. Now if you're going to look at the drawing here, okay, if you're going to look at the drawing here, here is just equal to this. So therefore this angle here is just equal to the angle here. Okay? Okay. Alright? So therefore, let's have an example for this. Remember this, huh? Remember this. Alright. This one here should be equal. Alright. And this one here is also equal because they are on the same segment. This one here also in the same segment. Alright, remember that? Remember in the parts of the circle, the segment part here. So therefore, once the circle or the line of the circle are on the same segment, they are equal. Okay, let's have an example. Let's do a circle here. Now okay, let's have a circle here. Yeah, example. Alright, example. Okay, if let's label this as A, B, C, and D. Now if ABC is equals to 44 degree, find ADC. So therefore, if ABC here, this one here is 44 degree, you have to find ADC, the angle here. Now, since they are on the same segment, so therefore, okay, since they are on the same segment, so angle ADC is also equal to 44 degrees. So this one here also is equals to 44 degrees. Alright, because they are in the same segment. Remember that, alright? Because they are, since they are on the same segment. Alright? Because they are on the same, again, because they are on the same segment. Therefore, the ADC is also equal to 44. Okay? So it is 44. Question? Okay? No question. All right. All right. Next we go for the next theorem, the circle theorem 4. Now the circle theorem 4 is a cyclical quadrilateral where all the vertices touches the circumference of the circle. All right, look at this. All the vertices touches the circumference of the circle. And you have to pay attention. Opposite angles in a cyclical quadrilateral adds to 180 degree. Okay, opposite angles in a cyclic quadrilateral gives you 180 degree. So therefore, which one is opposite? All right, this one here is opposite to this one here. All right, again. All right, this one here is opposite to this, and this one is opposite to that. All right, this one is opposite, and this one is opposite. Now, opposite angles is equal to 180 degree. All right, let's have a example. Let's do a circle. All right, let's have an example here. If I have here A, B, C, and D, and I have here a measurement of 102 degree, this is here is 84 degree, this is X, this is Y. Example. If ABC is equals to 84 degree, find CDA. All right. If ABC here, ABC, all right, ABC, this one here is equals to 84. So what is, since they are opposite, what is angle D? All right, so therefore the way you're going to do that is you subtract it to 180. So 180 degree minus 84 degree. All right, minus 100 is equals to 96 degree. So therefore, CDA is equals to 96 degree. All right, is equals to 96 degree. So therefore, X is equals to 96 degree. Now, if you're going to solve for Y, solve for y, it would be 180 minus 102. The answer would be 78 degree. So therefore here y is equals to 78 degree, because opposite, yeah, opposite is equal to 180 degree. Alright, so I hope everything is okay with the first four rules, or the first four theorem about circles. Okay, now we go for the fifth theorem, the alternate segment theorem. Alright, the alternate segment theorem. Okay, the alternate segment theorem is the angles, okay, the angles between the tangent, the angle between the tangent and the side of the triangle is equal to the opposite side angle, interior angle. So you have to look at this. I'm going to mark this. If this one here equals to this, if this one here is equal to this, and where is our tangent point? The tangent point is here. Alright, this is the tangent point. Alright, and these are exterior angle, and this is interior angle. Alright, so remember that. So an interior angle is just equal to its opposite exterior angle. Opposite, remember that. Alright, opposite. Look at, mark the color. This one to this one to that. Look at the color. Opposite. Now I'll give you an example. Alright, this is our tangent point, and remember this is your tangent line. Alright. Okay, let's have an example. Alright, let's have a circle here, and we have one triangle here. Alright, we have a triangle here, and we have another tangent line that passes through here. Sorry. Alright, we have a tangent point that passes through there, and the angle here, alright, the angle here is equal to 19 degree. Let's mark this as A, B, let's mark it A, B, C, and D. This is E. Alright, now if, example, if angle BAD is equal to 19 degree, find angle ACB. Find angle ACB. Alright guys, remember this one here is read as angle. Okay, so if we're going to mark our example here, if we have BAD, you have B here. If BAD, this one here, BAD, that one here, is equal to 19 degree. This one here is equal to 19 degree. Find, you have to find for ACB. ACB. CB. So therefore you're going to look for the angle here. Correct? Correct. So therefore, but it says there that the opposite exterior to its interior is equal. Okay? The word is equal. So therefore, if this is 19 degree, so therefore x here is equals to what? Equals to 19 degree. Okay? Are you following me? Is equals to 19 degree. Alright? Equals to 19 degree. Okay? So if, because they are opposite, this is the exterior and this is the interior. Alright, since they are opposite, interior and exterior alternate, that's why it is called alternate angle. Okay, that's why it's just called alternate, because it's alternate angles, they are equal. Alright, alternate interior and exterior angles, the results is in between equal. Okay, I hope this one is clear, and that is our fifth theorem about circle. Now let's have just a quick review for this. First, we review about the circles, part of the circle. Remember that because we are going to use that in our next discussion. You have there a segment, a chord, a diameter, a circumference, a center or radius, a point, a tangent line, a tangent point, and a sector. Diameter is 2 times radius. Radius is diameter divided by 2. Next, the first circle theorem is the angle at the center. Remember that the circumference angle is gives twice so that you are going to get the center of the circle. Now you have an example there. I hope it is clear. The second theorem is angles in a semicircle, which gives us a 90 degree angle or a right angle. Right? This one here is called the right angle. Next is the next theorem is the angles in the same segment. They are in the same segment, so therefore they are equal. Next one is the theorem of cyclical quadrilateral. There's a quadrilateral inside a circle. You make sure that those 4 endpoints or vertices, all right, this vertex here, a vertex here will touch the edge of the circumference, and the opposite angles to which is equals to 180 degree. Now the next is the fifth theorem that we're going to discuss today is the alternate segment theorem. Alternate interior to exterior, they are equal. All right, I hope it's clear. You don't if you have any question, feel free to ask, and remember there will be worksheet, so feel free to answer it. If you have any question, don't hesitate to comment it down so that it would be answered, and I'd be very glad to answer your question. I hope it's clear. The 5 theorems of circles and the parts of the circle. All right, if you have a question, feel free to ask, guys. Thank you.